Let me just bring up the participants menu so I can actually see who's here as well. All right, we got a couple of people. Cool. So yeah, this talk is going to be on Python exploitation. I'll be honest, when I first got asked to talk about Python exploitation, kind of thought about it and I went, I mean, what is there anything that's really, specific to Python that we care about? And the answer is yes, but in the vast majority of circumstances, if you're dealing with Python, the vulnerabilities you're going to be exploiting are more general ones that are applicable across language, things like XSS and other language agnostic things. Or if you're doing a reverse engineering challenge, then reversing Python and reading Python code like you would any other language. But there are areas and prickly bits to be aware of, just like there are with PHP. And so I thought, this is actually a pretty good opportunity to do a deep dive into Python and some bits of how it works, especially given that, well, everyone learns Python at Monash University, but people don't really understand how it works, and certainly not to a great degree. Before we get started, I'm Richard. I'm a third-year comp sci student at Monash. I was vice president of this club, and I generally hang around, do some CTSing once in a while, although less so this year as I've gotten busy with other things. Security is sort of a side gig for me. I'm mainly looking to do more software engineering stuff, but it's super interesting, which is why I'm giving a talk on it. So I'm going to try and keep the theory brief, but I think it is important to know a bit about how Python works, and some of this is going to be really basic high-level stuff, but I think it's good to make sure we're all getting off on the same foot. So Python is what's called an interpreted language, which means that the code is executed on the fly, as opposed to something like C, which you compile it into the machine code, and then the machine runs that code. Python has an interpreter that runs on top and actually takes in the Python code and goes through it as the program is executing. That's the high level thing that everyone tells you about. What they don't tell you about is that typically code is actually compiled into an intermediary Python interpreter bytecode, which is the thing that's actually interpreted. There are actually multiple distributions of Python. Typically, if you're downloading Python, you're downloading Cython or C. I don't actually know how to pronounce that, but there are others, including PyPy, which is a just-in-time interpreter, just-in-time compiler for Python. And you can actually, also you can see the bytecode by using the compile function in Python. One of the big things that's really important to be aware of with Python is that it trusts the author as a matter of philosophy and principle. That means, as opposed to languages like Java, where, say, classes can have hidden or private variables and methods that hide away internal behavior, Python says, knock yourself out. You're the user, do what you want. You can suggest that something be private using the notation of double underscore something double underscore. That's what's known as what we call dunder, just as shorthand. But you can look out whatever you want. You can override whatever you want. That means if you don't like the way Python does imports, you can literally override the double underscore import double underscore function and hack Python so that imports are different. Also, Python 2 versus Python 3. This is a decade-long thing and piece of fragmentation in the community. Python 2 is now officially deprecated and does not receive security updates. If you're working with code that uses Python 2, dear Lord, I'm sorry. Cool. So another just bit of general high-level theory before we get started is just sort of how you should think about reverse engineering, because a lot of Python challenges and a lot of time when you're dealing with Python, you're going to have source code available. And when you're doing that, you should think in terms of sources and sinks, where sources where you have ability to control input, and sinks which are dangerous functions that you might want to try and control. I think it's really useful to think about this sort of thing in this sort of way, because it allows you to draw paths or graphs from what the things you can do to the things you want to do. and in doing so, figure out a chain of mutations or transformations that you need to do in order to get some condition to occur. Most of what I'm going to be talking about today is sinks and dangerous functions and how you can exploit those dangerous functions. So there are some basic obvious ones that Python has and basically every single interpreted language has. Eval and exec, both dangerous functions by design. They take Python strings and they execute them as code. I do want to raise this one because it's kind of insane and is the sort of thing that you might genuinely run into in real life as well as in a CTF. And that's that in Python 2, input as a function evaluates the input given. It doesn't actually record it as a string or return it as a string. This is incredibly stupid, and this is not a thing in Python 3. In Python 2, the function is that you're supposed to use is raw input, which is what Python 3's input does. This is going to be the first demo because it's insane, and I think it deserves to be looked at. So I think, just can someone in chat confirm that they can see my screen share? Actually, I don't know if I can see chat.
Yeah, we can.
Awesome. Cool. All right. Let's see. Python 2, Py2 input. So this is the code that's been executed. While true, print, enter an input. That should be pretty simple. That's something that you might do in a hello world. And if I enter, say, hello, you'll see that that doesn't actually work. And that's because it's evaluating the input. So if I enter true, it's going to return true. If I enter true equals true, it's going to evaluate that and enter true. That's pretty exploitable and is basically exploitable in the same way that all of the other things that I'm going to be talking about today are. But I wanted to flag that as the first of many prickly bits that you should be aware of and that, if you see, should probably raise some red flags. The second demo thing that I want to do is format string attacks. Many people think that format string attacks are only really a problem with C or C++ or C-like languages. That's wrong. Does anyone want to read this code and, or actually no, I'll go through it and then we'll see if anyone can think of and point out the vulnerability and how you might exploit it. So we have this config variable that's not actually getting used in the code, but sure, that exists. We've got a class that's a car, only has one attribute, it's a name, and it's representation. So this dunder repr function is what happens when it gets evaluated into a string. So if you did print of a car object, it would return self.name, which is whatever name it's been initialized with. It's got this format car name function, which takes a string, formats it with name equals car, which is passed in. All right, cool. So that's our setup. We've got a car, Tesla Moon Car is its name. So this is Python 3, by the way, so input is not a vulnerable function here, but it is a source which we control, which means it's of interest. So what we're doing here is we're entering a string to be formatted, and we're saying use bracket name, close bracket, which is the Python string format syntax for the car name. And we're saying print format car name in string and my car. So the user can't control what the car is. All it's doing is replacing whatever instance of name with the car's name. Does anyone want to suggest how this might be vulnerable before I go through and demonstrate it? I'll give it, I don't know, 10, 15 seconds while I actually bring the demo up. Escape the string of quotes. Good idea, not in this case. In this case, Python's input function is handling the string, and that's safe. Specifically, we should be thinking about, okay, we know this is a format string attack. We know that this name thing is getting passed in. Don't worry if you can't find a vulnerability. Part of this is an exercise to get you to think about it and then to go, oh, okay. All right. So this is our code, format string.py, and let's execute it. Python 3 format string.py, and the string to be formatted, use name for the car name. So let's go through and make sure it works the way we expect it to work first. Use name. All right, so before we execute this code, what we expect it to do is replace this name with Tesla moon car, and everything else stays the same. All right, that works. Whoops, that is my cheat sheet. Actually, I will bring that up for my own benefit, but no, that's fine. I don't need a cheat sheet. All right, so we've got that working. Now, remember what I said at the start of this talk, which was that Python explicitly trusts its users and it has a whole bunch of hidden functions. What's actually happening here is that this format string is evaluating what's ever in here and replacing it with whatever's evaluated. So in this case, name is what's being evaluated and name is the car. So what's happening is inside this, it's actually just evaluating my car. And so if we replaced the brackets name in our format string with my car, then it would actually return the same thing. My car is a car object. And cars have and objects have their own functions as well as our car object, right? If we actually look and use the dir function on an object, so let's copy this in and have our own car. X equals car, moon car. We can actually see that there are a whole bunch of hidden functions here. Get attribute, greater than, hash, init, undone the class, weak ref, and we have name, which is an attribute. So then, what I'm getting at here is that we can actually use those functions inside this format string because that's what's getting executed. So, can anyone suggest what might happen if I execute this bit of code here? So this is inside our program. I've got bracket name dot underscore underscore init. So I'm not executing it because I'm not using any brackets. So, but does anyone want to take a guess at what this might return? Return a reference to where the function is stored in memory? Exactly. Bound method car dot underscore underscore init of Tesla moon car. That's interesting. That means we have control of the input in a way we shouldn't. And okay, that's kind of neat, but if we can only access like dot underscore underscore init and we can't even see what's going on, well, that's not exactly a shell. Here's the thing though. Python gives you access to everything, and this is a recurring theme. Let's have a look and explore what we can do and how we can chain our way using Python hidden functions in order to get secret flag. Because remember, secret flag and config isn't being used anywhere. Like, it exists in memory and that's it. Well, we got our car. We got underscore underscore init. Actually, that copy. So let's go back into our interpreter and say, get a new car, moon car, cool. So we said, okay, well, we can access underscore underscore init, and that's a method. Well, I don't know, let's have a look at what properties our method has. All right, we got call, class, delata, see, blah, 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 format, reduce, Okay, so we've got more stuff here. One sec. One of the attributes that we're looking for, and I don't know why it's not actually showing here, it might be hidden, but either way is useful to know, is the __ globals attribute. So functions in Python have to be able to access globals. They have to be able to access, the variables that you expect them to be access, and that's stored and accessible through the __ globals attribute. And here we can see all of the global objects stored in memory. So we have import, which is stored in memory. We have the built-ins module. We have the car. And somewhere along the line, we should also have config, which is stored in memory. So what we can do then is we can chain things together in order to get our secret flag. So let's run this again. Let's see, what's this? Format string. And let's validate and make sure things are working. So name, we have to have name in because that's how we access things. It replaces anything that's name with my car. So now we should be thinking, okay, it's my car that we're executing from here, dot __ init, that's nice, dot __ globals. Let's try that. Okay, we've got our globals, that's working. And we can see config here. Now, it turns out that this is actually just printing it out straight, and at this point you have the flag, but if you wanted to be neat about it, you could actually access it just like a dictionary in Python. So config and secret _ flag. Oh, well, I messed up somewhere there, but you get the point. So yeah, Python has format string attacks. String formatting, just like in C and other languages, is an area that you should be watching out for, because in this case, the fatal mistake that's happening here is we're passing the car object to format instead of a string literal. All right, next, Python jails. So what I did there was basically how you'd also escape from a Python jail. The underlying core principle is exactly the same. Python trusts the user. So Python, before I get ahead of myself, Python jails are a type of CTF challenge which are really, really contrived, but really, really fun, which is basically that you've been given a limited Python shell and you can't do things, and how do you escape from there, and pwn. So we've learned that we can use done the functions. We've learned that we can use dir to actually dig into the underlying Python hidden magic and figure out what's going on. So we're going to walk through breaking a jail together because that's kind of fun. So I have a really basic Python jail here, which is actually stolen from a CTF somewhere. This basically just runs whatever code you put in. Python jail.py. So this is a nice challenge. It gives us the code, and then it goes and tells us what it's searching for, and then it runs whatever code we give it. Here's the thing though, if we try and type import, or if we try and type eval or exec, or any of these keywords, it says no, and then it exits. And I'm very, very sad. So the way we solve this is much like anything else, in that we have access to things like __ built-in, which, well, that won't show us because it's doing exec, but if we go into Python, shows us that we have a whole bunch of stuff we can access here. So then, how do we solve this? Same way we solve the other things. We go and we build an exploit chain, and then we figure out how to do things that they don't want us to do. So in this case, I have the solution pre-prepared because I don't want this to go for too long. But doing this should let you understand that this sort of thing is possible. Actually, I'm just going to paste this in because that'll be faster. And then I'll explain this exploit chain. So that's executed. And what this has done is it's imported the OS module. From there, what we'd want to do is build another chain to do something like reverse shell, but I'm not doing that here. Built-ins is the Python module that contains all of the built-in functions. So that's things like import, that's things like print. We're turning that into a dictionary, and then we're accessing the import module, which is defined as __ import __. Because import in lowercase characters here is getting filtered out, that's defined as a string, and then we're turning it into a lowercase here. And then we're executing it using brackets on OS's lowercase representation, thereby executing import OS. And if we show that here, then we see module OS from user lib python os.py. So then we could run whatever OS commands we wanted using the Python OS library. Gosh, we're already at 30 minutes. Well, not quite. Yeah, so Python jails normally aren't, the whole point of Python jails is that they restrict your toolset and they ask you to be sneaky. So you should really just be thinking about it in the same way that you think about any sort of other string filtering type challenge. How do you bypass XSS filters? How do you bypass SQL injection filters and WAFs? You do it by concatenating strings, finding alternate modules that might be installed in the system but haven't been filtered out, by doing weird type conversion. One of the places that is actually really that is useful to check out is code golfing on Stack Overflow, because the people over there use all sorts of weird tricks to try and lower their character count. All right, this is the last big demo, and then this is the last big demo, and then I'll touch on a couple things, and then that'll be the end of the talk. This is something that honestly I haven't encountered that much, but is actually particularly important to know when you're dealing with Python in certain applications, and this probably pops up more in the real world, honestly. Python has a binary data representation format that it uses to serialize things, and that's called a pickle. So if you see any references to pickle in a challenge, or you happen to see a piece of code imports the pickle library, you should think about this. So this is a very simple code snippet that I stole from a Medium article. It pickles this class, and it represents it in this binary code. So that's pretty cool. I mean, we can store data. Pickles represent objects, and objects have data, and objects have functions, which in Python is also data. And in particular, Pickle is not designed as a secure information format. Pickles are, much like the rest of the Python philosophy, very, very trusting. One of the functions that we're really interested here is that Pickle allows objects to declare how they should be depickled using the reduce function. So then, I've got some demo code here that shows how, very simply, we can execute our own code and screw things up. So we've got our normal object, which we're going to see works as expected. So we make a person, we pickle it, and then we depickle it. And that creates a new object called with the name Richard. All well and good, perfectly fine. Now I have this malicious pickle here. So the reduce function gets encoded in whatever you pickle, and then it gets called, and that's how you tell Python how you want your object to be depickled. That's arbitrary code execution just straight up. And because I wanted to make this example slightly more realistic so you can understand how you can use your RCs in all of the other examples, I've actually got this bit of code here. So for those of you who are more experienced, you'll recognize this instantly as a reverse shell. For those of you who aren't, basically, getting access to Python is all well and good, but most of the time in the real world, you want to get beyond Python. You want to be able to execute code and your own commands on the server itself. So, well, Python has the ability to execute commands on the server itself using OS, and we can make life a hell of a lot easier by creating a new connection called a reverse shell, which is basically when we tell the server to send a connection out to us that says execute whatever I type in. So I'm going to basically tell my system to listen on port 8080 using netcat. All right, that's now listening. And then I'm going to run this. So what we expect to happen here when I replace new person with fake object is Python is going to dump it into a pickled binary format. Then it's going to load it. In loading it, it's going to create the malicious class, and it's going to run the __ reduce __ function, which is going to run this reverse shell. Let's execute it. Didn't save it. Let's execute it. Oh, I've got a connection from localhost, and Python isn't returning anything because it's waiting for this to exit. Because this is an open connection, it's not going to exit unless I exit the connection. So that's a reverse shell, and basically what's happening here now is anything that I type into here is getting piped through localhost up into Python, up into the shell that I've created independently of Python. So if this were a server, I'd have access to the service terminal and I'd be able to say, do, cat flag.txt and win like that, and or do further privilege escalation. And, this is the sort of thing that you're trying to do with all of the previous RCE vulnerabilities. So if you have the ability to get arbitrary code execution using eval, import, or format strings, then boom, you've managed to escalate from control over Python to control over part of the system. I'm not going to dedicate much time to this, as you can see by the slide, but I think it is worth noting. One of the really, really common challenges you'll see, especially in beginner CTFs, is Flask template injection. Basically, much like the format string attack that I showed you before, in certain versions of Flask, there's a bug that allows you to create your own templates and run your own code by using the double brackets. So if we go back to format string, here we intentionally allow you to use bracket name bracket. That's really bad practice, and well, typically you don't want users to be able to control template strings, and templates, which is what this is. Flask did that, which basically introduced this vulnerability, and for some reason it's really, really popular. It's not something that you're likely to see in the real world, in my opinion, because it's a pretty major vulnerability and it's been fixed for a while now. But because, we do CTFs, I think it's important to touch on so you can recognize anything that says Flask or is overtly yelling at you about Flask and templates. You should probably be thinking about this vulnerability. All right. that's all I have prepared. I wanted to keep this relatively short because I know it's assignment season. I know people are getting, like have stuff to do. So that's the material I have prepared. That's the material that I really wanted to touch on and that I thought was important to talk about. I'm happy to take any questions. If not, then yeah, hope you enjoyed.